Oh, hi, welcome back to the enzyme kinetics derivation. So we have just completed the rapid equilibrium assumption. Now let's move on to the second case, where it's so-called the pseudo-steady state case. A pseudo-steady state case is where the rate of us reaching the equilibrium is very slow, and as explained in the earlier videos, the equilibrium is never reached, and then we have a case which is called a pseudo-steady state. So let's get back to this. Now it is slightly a little more complicated. When you have V, which is the rate of production of your desired product, and it will be equals to K2 times ES as usual. But what is K2 times ES? Well, according to the equation, under the condition that it is the concentration of ES is constant with respect to time, so the ES dt equals to 0. That means the rate of consumption equals the rate of production of ES. So this is from the equilibrium side, and this is the rate of consumption, where ES is converted into the product. So I can just write this here, V equals to dP dt, and equals to K2 ES. That's our first one. And substituting this ES for this, we have this again here. Okay? Alright, so now how do we simplify this equation so that we have some kind of a similar expression that we have before? So again, we have to make ES the subject. So that is done in equation 2. So let's make ES the subject again. K2 ES. So let me shift this to this side. Plus K inverse times ES equals K1, and you have this bracket E times the substrate concentration. Okay, so far okay? Hope so, yeah? Anyway, what we have to move on is this. We have to now get rid of this this E. We have to get rid of this E over here. So what is that E equals to? So referring back to our enzyme balance. So ES equals to E naught minus E. So let's make E the subject again. E equals to E naught minus ES. So now we have an equation E specifying things in something we know, which is the enzyme concentration initially, and of course the enzyme substrate concentration. So let's substitute E into this equation so we can get rid of this variable. Or rather, substitute E into this equation. So let's see, K2 plus K inverse times the concentration of ES equals to K1. Then let's bracket it here. E naught minus ES. Let's close this, and we times the S outside. Oopsie. Times the concentration of S. Alright, so let's do this. Let's separate things out. K1 E naught times S minus also K1 times ES into S, and of course let's bring this over here, so that we can combine all this ES into one term. So let's do K2 plus K1 into ES. Now this will have to shift here, so plus K1 ES into S equals to K1 Alright, hope you don't mind the noise outside, but yeah, don't worry about it. Hope things are clear so far. So we have this situation where we have brought this over to the left hand side of the equation. So let's just make it again a little neater. So we have this thing, which is the k2 plus k1. Oh, sorry, it's k inverse. I made a mistake there. K inverse, k2 plus k inverse plus k1 into S, concentration of S, times ES equals k1 E naught into S. And of course, finally, you can finally make ES the subject, the concentration of ES the subject. So it's this k1 E naught S over k2 plus k1 or k inverse plus k1 into S. Okay? Alright, so to make this neater, let's divide the top and bottom by k1. So you have an expression like so. k2 plus k inverse over k1 plus S. So I'm dividing the top by k1. I divide the bottom by k1. Now I have this slightly neater expression here. And for this case, we have this lumped constant over here, which we can consider, similarly to our earlier case. You can lump this into some kind of constant. You just call it again Km prime. I mean, it's for your convenience if you want to do this. If you don't want to, repeatedly write these three constants into one fraction, it can get a little tiring. So you'll just leave it as that, for simplicity's sake. And again, let's substitute this back into our earlier equation. So let's keep on track this time. Yeah, let's substitute this back into our equation, and we have this dp dt equals to k2 into ES, and that's equals to k2, substituting the ES part, E naught S over Km prime plus this S, and that, as described earlier, is Vmax over Vmax times S over Km prime plus S. Of course, this time the Km prime represents this constant here. So it depends on how you derive it. You might see enzyme equations, in this kind of form, and this is how we derive those equations. Okay, so thanks for watching. Hope you have gotten some clarity on how these equations are derived, and I'll see you guys next time. Bye bye.